Okay, welcome to Pre-Calculus Section 2.3. This is the next video on Section 2.3. We've already kind of watched one, so we're going to kind of do a recap of some of the stuff, and then hopefully you've learned more and more and more so we can continue to move on here. The first main thing that we learn from this section is what we call end behavior. And what we mean by end behavior, we're talking about what is the graph of the function doing at the end. Because remember, polynomials are these nice smooth graphs that do some twisting and some turn. Actually, they turn. They don't necessarily twist around on themselves. So we want to kind of learn about what's going on in the ends. And when we say the ends, we mean what's the graph doing at the ends, to the left and to the right. So we're interested in what's happening as x goes to the far right. That's all the way towards infinity. And what's happening as x goes to the far left? That's negative infinity. So we're kind of saying, hey, let's look to the right. Where's the graph going? Well, in this particular picture, the graph's going down. What's going on as we look to the left? That's right here, towards negative infinity. The graph is also going down. So we would say, as x approaches infinity, the function itself is going towards negative infinity, meaning down. As x approaches negative infinity, the function itself, or y, is also going down. So it's all about looking to the right and looking to the left, and where's the graph going at the ends. So let's do another example so you can see a second example of what I'm trying to talk about here. So let's make another graph here. And let's have this graph look like this. Okay? And again, I'm focusing on what's going on with the graph at the ends. So we say, okay, as I look to the far right, in terms of x, remember x is the horizontal, so x is left and right, looking left and right. What is the function doing? Well, remember the function is y. Y goes up and down, up and down. So as I look to the right, the graph is going up towards infinity. As I look to the left, that's negative infinity for x. As I look to the x, or to the left, remember x is the moving to the left, right? Like I said, x is left and right, right? So negative infinity for x will be looking to the left. Where's the function going? Well, the function is y, and look at it. Look at the graph. It's going down towards negative infinity, okay? So these graphs can do different things. The key idea is you have to look both at x goes towards infinity, that's moving your head to the right, and x goes towards negative infinity, that's moving your head to the left, and then looking where's the graph going at those directions. So it's either going to be going up towards infinity, or the function is going to be going down towards negative infinity. That's the whole idea. Now we want to figure out how can we know without looking at the graph what's going on. Well, it all comes down to the degree, and it comes down to the leading coefficient. Okay? The leading coefficient, again, is the number in front of the largest exponent. So the degree could be even, or the degree could be odd. Okay, remember the degree is the largest exponent of the polynomial. The leading coefficient could be a positive number, or it could be a negative number. Okay, so if we have an even degree, so if the degree is 2, 4, 6, 8, 10, 12, 14, okay, you get the point. Even degree, okay, that's an even degree with a positive coefficient. Both ends go up. So both ends of the graph, who cares about the middle? But both ends are going up. If you have an even degree and a negative leading coefficient, both ends of the graph, both ends are going down. Again, who cares what's happening in the middle? But both ends are going down. Okay? Now let's switch it up real quick here and let's talk about an odd degree. So if your degree is odd, that's 3 or 1, 3, 5, 7, 9, and so forth, and a positive leading coefficient. Here's what's going to happen on this one. The left side is going up. Who knows about the middle? And the right side is, the left side is going down. Right side is going up. If we have an odd degree with a negative leading coefficient, let's show a picture of this graph. And let's see here. On this graph, the left-hand side is going up. The middle could be doing a bunch of turns. And the right-hand side is going down. So left up, right down. So even degree, both are going the same direction. Both up or both down. Positive both up, negative both down. Odd degree, one's up, one's down. One's up, one's down. Positive, left's down, right's up. Negative, left's up, right's down. All right, so let's do some examples with this so you can see what I'm talking about. All right, so let's say we have the function f of x equals negative 3x to the fourth plus 7x squared minus 8x. Okay, so let's see here. As I'm looking at this, the degree is the largest exponent right there, 4. So this is a fourth degree. Fourth degrees are even, 4 is even, and the leading coefficient is negative. Look at the leading coefficient is a negative 3. So even tells me, right, 4 is even. Even tells me that both values, both ends are doing the same thing, both up or both down, but because the leading coefficient is negative, they're both going down. So here we go. As x goes to the right, and as x goes to the left. So I have to analyze. As x goes to the right, I know that the graph is going down. How? Because, well, I just got done explaining that it's negative. Negative with even, they're both down. Negative with even degree, they're both down. So as I look to the right, the function's going down. And as I look to the left, the function's going down. So the function is going down both on the left side. The left side would be right here towards negative infinity, and on the right side towards positive infinity, the graph's going down. Let's look at a second example here. Let's try to squeeze it in. A function like this. Let's see here. 7x to the fifth minus 8x squared plus 9. Again, fifth degree. Largest exponent is a fifth degree, so it's a fifth degree polynomial, and the leading coefficient is positive. So fifth means that's odd. That means one side's up, one side's down. Positive means the left side's down. Who knows about the middle? Right side's up. So how do we talk about that? We say as x goes towards infinity, as I look to the right, the function itself is going up. As x goes towards negative infinity, as I look to the left, the function itself is going down towards negative infinity. Sorry, it should be an arrow, not an equal sign, arrow. So again, the x towards infinity and x towards negative infinity always stays the same because you look right, you look left, and then you're concerned about where's the function going. That's what could potentially change. So hopefully end behavior makes sense to you guys. All right, next up for us to talk about is finding zeros. Zeros are also known as solutions. If you have a quadratic, we have already learned that you could either use the quadratic formula or you could factor. But what about if you have higher degree polynomials? So let's look at several examples here of higher degree. I mean something like this. Let's see here. X cubed plus 11x squared plus 24x. That's obviously a higher degree than 2. You cannot use the quadratic formula here, because there is the quadratic formula is only for quadratics of degree 2. This is degree 3, so I have to factor. So you guys have got to get used to factoring. So let's see here. I'm going to take out an x. All three terms have an x. I'm going to take an x out. I'm left with x squared plus 11x plus 24. And now I'm going to have to continue to factor. Let's see here. That quadratic can now be factored. Notice I left that x out in front. Can't just get rid of it. Let's see. X and x makes the x squared. I'm thinking 24 could be 8 and 3. And that makes sense because then they will add up. The 3x and 8x make the 11x on the inside. So we have 3 factors. We got 1 right here, 2 right here, 3 right here. Any one of them could be 0. X could be 0, x plus 8 could be 0, x plus 3 could be 0. So that means here's one solution. It's already set to go. The other one could be negative 8. That's another solution, or 0. And the other one would be negative 3, another solution, or 0. And again, all I did was subtract 3, subtract 8. Easy to find. All right, let's look at another example. Let's look at a second example here. So we have the function, and I want a higher degree one here. So let's do 2x cubed minus 4x squared minus 16x. And again, I cannot use the quadratic formula. I don't have an a, a b, and a c here because this is not quadratic, it's cubic. So I have to be able to factor it. Let's see here. All three terms have an x, so I could take an x out. But I also notice all three terms are divisible by 2, so I could take out a 2x to make my life easier. So I'm left with x squared minus 2x minus 8. If you don't believe me, just double check. 2x squared, negative 4x squared, I'm sorry, that'd be a 2x cubed, negative 4x squared, and a negative 16x. But let's keep factoring. Leave that 2x there. Let's try to factor what's left over. X squared is x times x. 8 is 4 times 2. And I need that 4 to be negative and the 2 to be positive. That way I get a 2x and a negative 4x, which makes a negative 2x in the middle. So I have 1, 2, 3 factors, any of which could be 0. So I have to set all of them equal to 0. Most kids forget about this one right here. Don't forget about that 2x. Divide by 2, I get x equals 0. That was easy. I forgot to set that equal to 0. Add 4, I get x equals 4. Subtract 2, I get x equals negative 2. So be careful. They're not that hard. You just got to take your time. All right, let's see here. Let's do a couple more here. Let's see here. Let's do a tricky one here. Number 3, f of x, function 4x to the 4th. That's a 4. Minus 28x squared plus 48. So one thing I notice here is that all of the terms do not have an x, so I can't factor an x out. But all the terms are divisible by 4, so I could take a 4 out. So I get x to the 4th minus 7x squared plus 12. Now, I got to factor this. I mean, there's no other way to do it other than factoring, so I got to really take my time here and try to figure this out. X to the 4th could be x squared times x squared. That definitely makes x to the 4th. 12 could be 3 times 4. Now let's see if this works. That's going to be a 4x squared on the inside and a 3x squared on the middle. If I make both of them negative, I'll get a negative 4x squared and negative 3x squared, which makes negative 7x squared. That works out. And I get that positive 12 in the back. So I got 1, 2, 3 factors. Let's see here. This first one would be 4 equals 0. Well, there's no x there. 4 can't be 0, so that's out the window. X squared minus 3 could be 0. Let's see. Let me add 3. I get x squared equals 3. How do I get rid of a square? I take the square root. So I get x equals positive or negative square root of 3. So no big deal there. And let's see over here, I get x squared minus 4 equals 0. So I get x squared equals 4. Square root. That gives me, when you take a square root, don't forget plus or minus. And that's a perfect square, so I get 2. So I actually get 4 solutions here. I get 2, negative 2, the square root of 3, and negative the square root of 3. Sorry those didn't work out so nice, but hey, that's what happens. All right, let's see here. So hopefully that makes sense here. We're going to do one more kind of a tricky one here. This is the 4th example. And the function itself is x cubed plus 3x squared plus 5x plus 15. And this is a tough one because this is a 4-term third-degree polynomial. Notice not all the terms have an x, so I cannot take an x out. And not all the terms are divisible by the same number. There's not one number that goes into all of them, especially with the 1 right out in front here. So I have to be able to factor this. And trust me, it can be done by what's called factor by grouping. So here's how you factor by grouping. You look at the first 2 terms, and I notice I could take out an x squared. By the way, you could only factor by grouping if you have 4 terms, so you got to be careful. Okay, if I take out an x squared, I get x plus 3 right there. Right? X cubed plus 3x squared. All right, back here, between these 2 terms, I'm going to take out a positive 5. And I'm left with x plus 3. 5x plus 15. So it does check out. And what's beautiful is look at this now. Both of the terms have an x plus 3. So that's just a number. Remember, x plus 3 is just a number. So I'm actually going to factor out that number, factor out the x plus 3. And when I take that away from here, I'm left with x squared. Take it away from here, I'm left with a plus 5. So I get x plus 3 times x squared plus 5. So I have one of these guys, this guy or this guy, has to be 0. So x plus 3 could be 0. That's an easy one to solve. X equals negative 3. Boom. Okay, x squared plus 5 could be 0, and I get x squared equals negative 5. Subtract it over, right? Square root, square root. Uh-oh, can't have a square root in negative, so that produces no solution. So it looks like I have only one solution right there, x equals negative 3. All right, so hopefully you're a little bit better now at finding zeros. You just have to take your time, and you got to be able to factor. All right, let's talk a little bit more about factoring. I want everybody to completely understand what factoring is. Let's go back to elementary school. If I said factor 8, everybody would say, duh, 4 times 2. So factoring is the idea of taking a number and rewriting it as a number times another number. So it's the same concept when it comes to polynomials. X squared minus 4 is nothing more than a number. Right? It's just one number. So I want to factor it. I want to write it as a number times another number. So I get x plus 2 times x minus 2. Hey, we factored. We have one number. We wrote it as two numbers. And again, double check your work. There's an x squared, the 2x, the negative 2x cancel out, and then there's the negative 4 in the back. Let's do this one. X squared, let's see here, plus 9x plus 20. Again, this is just one number, right? We want to write it as the product of two numbers, hence factoring. So let's see, that's going to be x plus 4 times x plus 5. There's your 5x and 4x makes the 9x, and 4 and 5 makes the 20. So it works out, okay? So the idea is I want to be able to give you, and then once you have factors, by the way, you also have zeros, right? So what's the 0 from right here? Well, negative 2, right? Negative 2 makes it 0. What's the 0 from right here? Positive 2, because positive 2 makes it 0. So it should make sense that you're making it 0 is why we're called zeros. How about this one right here? The 0 would be negative 4 because it makes it 0. How about right here? Negative 5. It makes it 0. So I want to be able to give you a factor, x plus 3. You tell me the 0. X equals negative 3. Do you see the connection? Because if I plug in a negative 3, I get 0. We should be able to fly through these. X minus 7, that's a factor. What's the 0? Oh, x equals 7. 7 minus 7 is 0. How about 2x minus 5? Okay, a little bit tougher one here. That's a factor. What number makes it 0? I got to do some dirty work. 2x minus 5. What number makes it 0? Add the 5. Divide by the 2. I get x equals 5 halves. Oh, x equals 5 halves is the 0. So it should make a lot of sense, okay? I could also, should be also able to go in reverse. I know I don't have a ton of room left here, but I'm going to go in reverse here. What if x equals 3 is a 0? What's the factor? X minus 3. Why? 3 minus 3 makes 0. Hey, x equals 10, let's say negative 10 is a 0. What's its factor? X plus 10. Why? Because if I plug in negative 10 plus 10 is 0. Let's keep going because this is so much fun, I know. We can even use radicals. If x equals radical 3 is a 0, what's the factor? Well, x minus radical 3. Don't let a radical scare you. It's just a number. Why? Because radical 3 minus radical 3 is 0. How about x equals radical 5 but negative radical 5? So what would the factor be? X plus radical 5. Why? Because negative radical 5 plus radical 5 is 0. Makes a lot of sense, right? Let's do an extra tricky one, right? This is a really complicated looking 0. 2 plus radical 7. We've seen these before when we solve quadratics. Sometimes you get this 2 plus radical 7. Well, what's the factor? Get ready. X minus 2 minus radical 7. Why? Because I had to plug a 2 in. 2 minus 2 makes 0. I got to plug a radical 7 in. Radical 7 minus radical 7 makes 0. How about this one? 2 minus radical 7. Guess what? Here we go. X minus 2. That way the 2 minus 2 makes 0. And then I need a plus radical 7. That way the negative radical 7 and the plus radical 7 make 0. Okay, let's do one more here, right? X equals negative 2/3. Okay. That's the 0. I need the factor. Make it easy on yourself. X plus 2/3. Why? Negative 2/3 plus 2/3 is 0. Now, some of you might not like fractions, so think about this. If I multiply this whole thing by 3, I would end up with 3x plus 2, because 3 times 2/3 is 2. Now this looks a little bit neater. And if you want to make sure that it is negative 2/3, take a look at this. Set it equal to 0, subtract the 2, divide by the 3, and you get negative 2/3. Oh my goodness, so easy. So hopefully you guys understand section 2.3 a little bit better right now. Hopefully you could do some worksheets over it to practice these techniques. It's really not that bad. All right, good luck.